On the 27th of December 2004, something hit Earth. It was not an asteroid. Nothing struck the ground. Nobody looked up and saw an explosion. The night continued as normal, but above the planet, satellites reacted, instruments were overwhelmed, and the electrically charged edge of our atmosphere changed. The attack had come from a star so far away that its light had been traveling towards us for roughly 28,000 years. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point it at the dead star behind that flash. We follow the force buried beneath its surface, the fracture that released it, and the invisible wave that crossed the Milky Way before touching Earth. Its name is SGR, 1806-20. It sits in a dusty, crowded region towards the center of the Milky Way. It is a magnetar, one of the rarest and most violent objects in the galaxy. It began as a massive star. For millions of years, pressure from its hot interior held gravity back. Then its fuel ran out, the center lost that support, and the core collapsed until more mass than the Sun was trapped inside a sphere about the size of a city. The collapse left behind a neutron star. Matter was crushed until atoms could no longer keep their familiar shape. In this remnant, the magnetic field became so intense that it was around 1 trillion times stronger than the field at Earth's surface. That field is not a clean cage surrounding a quiet ball. It pushes against the crust, twists the material around the star, and stores energy in a shape that cannot remain stable forever. From a distance, none of that tension is visible. The star is just a point hidden among dust and thousands of other lights. Even a powerful telescope does not see a cracked iron world. It sees brief bursts arriving from the same patch of sky. Then the crust gives way. A magnetar's crust is solid, but the magnetic field beneath and around it keeps changing. Pressure builds slowly in material that cannot bend like ordinary rock. When the crust suddenly shifts, the star can quake. The movement is tiny compared with the star. The energy waiting behind it is not. The crust slips, the magnetic field snaps into a new arrangement, and energy that may have been stored for years escapes as X-rays and gamma rays. On that December day, SGR 1806-20 produced a giant flare. The brightest part lasted only a fraction of a second. In that moment, the star released more energy than the Sun radiates in 150,000 years. The flare did not travel like debris from an explosion. Its gamma rays moved at the speed of light. They crossed dust clouds, passed other stars, and spread through the galaxy, while the magnetar itself remained far behind. The journey took about 28,000 years. When it began, humans already walked the Earth, but there were no cities, no satellites, and no instruments waiting to record it. Generation after generation lived and died while the flash kept moving. The last few seconds happened in complete silence. Space carried the radiation, not sound. Detectors on spacecraft around the solar system were flooded. Some could not count the incoming gamma rays because so many arrived together. The signal reached different spacecraft at slightly different moments, helping astronomers trace its direction. Part of the flash even reflected from the moon. On Earth, the flare changed the ionosphere, the electrically charged upper layers of the atmosphere. Radio signals passing through those layers carried the disturbance in their measurements. A dead star on the other side of the galaxy had left a signature above our heads. At ground level, almost nobody knew it had happened. There was no shockwave, no burning sky, and no sound. The atmosphere above us had absorbed the encounter. That quiet is the most unsettling part. The event was powerful enough to alter the edge of our atmosphere, yet distance reduced it to a signal that only instruments could reveal. A giant flare much closer to Earth could damage the atmosphere far more severely, but every magnetar we know is safely distant. This is not a warning that another blast is about to arrive. It is evidence of scale. A city-sized remnant released a flash. The galaxy diluted it for 28,000 light-years, and Earth still felt the result. The star did not explode apart. SGR 1806-20 is still there. After the Great Flash, its fading signal carried a trembling pattern that astronomers used to study the quake. It still rotates, its magnetic field continues to change, and astronomers continue to watch it. We tend to imagine danger as something large enough to see coming. A magnetar is the opposite, a dark point, smaller than a city, carrying enough stored energy to reach across the Milky Way. On the 27th of December 2004, Earth was touched by a dead star from across the galaxy. The planet protected us so completely that most of humanity never noticed. The lens does not blink. Subscribe, because next time we point it at a planet with no star, moving alone through the dark.